Okay, in this problem it has been given that acceleration is negative of square root of velocity and the motion of the body is rectilinear. It is moving in a straight line. And it is also given that the body comes at rest at t is equal to 1 second. It comes at rest. Obviously that means that velocity is equal to 0 at t is equal to 1 second. So they are asking what is initial velocity. What we have to find is v0, initial velocity of the body with which it started, because it should have some initial velocity. Otherwise, see, if initial velocity is 0, then the acceleration will be 0. If acceleration is 0, then there is no further increase in velocity and the velocity will remain as 0. So initially there was some velocity that we have to find. So like we have been doing up till now, what we have to do is find the expression of velocity. From there we can get the initial velocity, final velocity, velocity at any time. So the idea is to get the expression of velocity. We have been given the expression of acceleration. We have to get expression of velocity in terms of time. So as we do, acceleration is dv by dt. This is minus root v. Now we'll club the same terms together, root v with v and dt. So we'll bring this function of in terms of velocity on left hand side. That will give us dv upon root v is equal to minus dt. Now after coming to this juncture, we have been doing that we integrate both sides. Now this is a function of velocity v. It could be integrated in terms of v. So we have adjusted it such that dv comes with v and this is dt. The integration will be simply t. But we have to do it with proper limits. So let's do it. We'll integrate both the sides. dv upon root v. I'm writing root v as v ki power 1 upon root v as v to the power of minus half. Okay, because it helps. We know the formula of v ki power n. So we can easily find the integration of v ki power minus half. Properly we should write it like this. V power to the raised to the power minus half dv is equal to integration of minus dt. So v ki power n is integration of v to the power n is v to the power n plus 1 upon n plus 1. So integration of this would be v to the power minus half plus 1 upon minus half plus 1 with proper limits. Now the limit of integration, we start with t is equal to 0. There is some initial velocity, we are calling it v0, and we reach to time t and there is some final velocity, we are calling it just v. This is how we put the limits correspondingly. At t is equal to 0, what is the velocity? At t is equal to t, what is the velocity? And after integration we put these values. We'll see how. v0 to v, we have done the integration. Integration of dt is t. It is simply minus t, 0 to t. Okay. Now we put the limit. The idea of putting the limit is we put the upper limit first. So we just put v in terms of the variable. So v to the power half upon half minus, then we put the lower limit. Lower limit is v0. So v0 to the power half upon half. This is the integration of left hand side. Similarly, integration of right hand side would be we put the upper limit t minus lower limit, that is 0. This is simply 0. This is how we do the integration. Now this is 2 root v minus 2 root v0 is equal to minus t. So this is the expression of velocity that we have got. Now let's see what they were asking. They were saying that at t is equal to 0, body has come to rest. That means velocity is 0. At t is equal to 1 second, the body has come at rest. Now let's put t is equal to 1 and body has come at rest. That means velocity is 0. So this gives us 2 times 0 minus 2 root v0 is equal to minus 1. That means root v0 is equal to half. Initial velocity is 1 by 4. 0.25 considering all of them in SI units, meter per second. This is how you do. This should not be difficult for you, and this won't be difficult for you only if you do it by your own hands. So practice them. So I mean, it would be a good idea to stop at this stage and do it all over again on your own, thinking about every steps, grasping every steps. Okay. Now I think you shouldn't be having any problem in putting the limits. I'll just repeat it once again. We put the limit correspondingly, as at t is equal to 0, what is the velocity, and at t is equal to t, what is the velocity. At t is equal to 0, the velocity is the initial velocity, and at any given time t, which will be variable, we'll have velocity v, which again will be variable. But at t is equal to 0, the velocity will be constant, and both variable and constant will be put in the function one by one. First the upper limit minus the lower limit. That's how we do. Okay, now the second part of the problem, it was asking find the expression of displacement. We got the expression of velocity. Now all we have to do is find the expression of displacement. This we have done several times before. Velocity is ds by dt. Simply, velocity is given here, the expression of velocity. I will have to find v here first of all, then we can replace v by ds by dt. So v, 2 root v is 2 root v naught minus t. So root over v is root over v naught minus t by 2. V is v naught plus t squared by 4 minus root v naught into t. I just squared both the sides. This is what we will get. Yeah. Okay. So now this v is ds by dt. So ds by dt we can write as v naught plus 2 squared by 4 minus root over v naught into t. And finding ds from here is a part that is well known to you. You just have to integrate both the sides. ds is equal to v naught plus t squared by 4 minus root over v naught t into dt. To integrate both the sides, integration of ds will be s, and integration of this will be v naught t cube by 12 minus root over v naught t square by 2 plus v naught t. Integration of one is integration of just dt is t, integration of v naught into dt will be v naught t. So this should be the expression of displacement. Now we had enough practice on the calculus part that we have studied. Now you should complete all the exercises in kinematics up till the differential section, because there will be several exercises. Up till the differential part, I guess up till the third exercise of kinematics you should complete it. Now we'll move on to study real physics.